Hello students, welcome to part B of section 1.4 where we're looking at limits of trig functions. So what you might notice is that, okay, direct substitution may not always work, but you do want to test it out and that might usually work. And if that doesn't work, then some sort of simplification using some identities, maybe using some conjugates, that might be helpful in solving some problems. But what we're doing in today's lesson is we're going to be looking at something where that isn't even possible. So it'll be useful to know some of these special trig values. So let's get right into it. So I want you to graph f of theta equals sine theta on theta. If you're looking at most calculators, you can't put in theta, so you could just do like sine x on x, something like that. And we're going to pull up the table of values. I've already done this in the back end, but I do want you to still follow along and get these values on your calculator as well. All right, so in my table, which I've already done, I've noticed here, like, okay, so at negative 0.01, I ended up with, all right, just about 0.99 repeating. Then as I got closer to 0, the calculator basically just rounded it and said 1 and 1. And then on the upper end of 0, I got 1 and 1. And then at 0.01, I again got 0.99 repeating. So let's look at the limit of theta, the limit as theta approaches 0 from the left side. So here's 0, and we're approaching 0 from the left side. And pretty much as we start to round and see the tendency of all these values, it comes out to be 1. And then as we look at the limit as theta approaches 0 from the right side, same thing, we round all those values and it pretty much comes out to be 1. So as I look at the limit from both directions, the limit as theta approaches 0 from both sides comes out to be 1. So what can we say? Pretty much anytime I have sine theta on theta and the limit of theta is approaching 0, I can substitute it in and I can get 1. So now we're going to look at a similar function. This time f of theta is sine of 3 theta on 3 theta. And we're going to still, again, look at our table of values around 0. And starting with negative 0.01, I did end up again with pretty much 0.99 repeating. And then I pretty much got closer and closer to 1. The calculator was just rounding it to 1 for me. And then at 0.0001, it was 1 and then 1 again. And then at 0.01, I got 0.99 repeating. So again, as I'm looking at the limit as theta approaches 0 from the left side, a sine of 3 theta on 3 theta comes out to be 1. So from the left side. And then from the right side, it also came out to be 1. So what can I say? So the limit as theta approaches 0, a sine of 3 theta on 3 theta comes out to be 1. Because both of those left and right hand sides meet up. So let's look at the two problems. So I have sine of 3 theta on 3 theta. On the first one, I had the limit of theta approaching 0 of sine of 1 theta on 1 theta. All right, so where c is any constant. So any constant means it could be negative to any positive integer. So what inference can we make? So as long as I have sine of 3 theta on something that is equivalent, this bit that is going to always equal, so the limit of theta as theta approaches 0 of sine of any constant times theta on top of any constant times theta is always going to be equal to 1. We can make that assumption, we can infer that for any constant now. So now in a similar fashion, we have another special trig function, and we're going to be looking at 0 for our limit. So here's 0 in the middle, and again, take the time to graph this in your calculator, 1 minus cosine theta on theta. And let's look at the y values. So as I got negative 0.01, I got negative 0.0049. And then at negative 0.001, the calculator basically rounded these two to 0. And then as well on the right side of 0 on the upper end, it said also 0. And then at 0.01, it said 0.0049. Okay, so taking those values, what can I say that the limits are going to equal? Well, the limit as theta approaches 0 from the left, so as I'm approaching 0 from the left side, I get it approaching 0. And as I approach 0 from the right side here, I'm also approaching 0. So on both ends, since they're equivalent, the limit as theta approaches 0 comes out to be 0. So now I wanted to take the time just to write, like, okay, what are the two special trig functions that we have? And that's going to be useful when we need to do some direct substitution and we can't technically like rewrite any of the functions using identities. So our first one again was the limit as theta approaches 0 of sine of c theta over c theta equals 1. And then the one that we just learned about is the limit as theta approaches 0 of 1 minus cosine of c theta over c theta is equal to 0. So very similar to sine of c theta, we can also have 1 minus cosine of c theta. That's going to conclude this lesson. In our next lesson, we're going to look at what we've just learned in the last two sections, and we're going to look at all these practice problems for those. So make sure you stay in tune for how to do those particular problems. You can see that we're going to be finding each of the following limits in the upcoming problems as well. If you need help understanding, if you're not sure how to graph any of these, please reach out to me. I'm Mr. Hernandez, and I'm always here to help.